Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. I've got a great topic for you today. I'm going to discuss clustering credit card charges, and we're going to use a couple different techniques, three different techniques, actually six different techniques to find outliers and a series of credit card charges. Okay, so this is very important for a number of reasons, right? Picking the right clustering technique to use or right outlier detection method to use. I'm going to show you how to do that. We're going to look at unsupervised learning. Primarily, unsupervised is basically also known as clustering, where you don't tell the computer what to do in advance. The computer tells you what to do. Okay, so with a supervised technique like regression or classification, you tell the computer what you expect, and the computer will run the model, whatever you pick, and analyze the outcome versus the the expected outcome, and then it measures the difference between those two, and you can see how accurately the model is making predictions. Right? When unsupervised, when you're using an unsupervised technique like that, you don't tell the computer anything other than, hey, here's my data, you tell me what's going on. So that's the approach here. So we're going to look at three different clustering techniques, as well as z-scoring, isolation forest, and interquartile range, abbreviated IQR. So this is pretty cool. Let's get into it. Isolation, ISOL. I just sort of spelling mistake. Let me fix that. I'm a stickler about these things. Okay, so I'm going to go ahead and import the necessary libraries. NumPy is NP, Pandas is PD, random, and warnings, just to show off any weird warnings that pop up. Sometimes when you're using Jupyter notebooks, you get these messages that they look a little scary. It's nothing more than, hey, just be aware of this, but it looks kind of funky, so I like to turn those things off. And then we have three libraries for three clustering methods that we're going to use. So I have some data that I basically made up. This is not real credit card data for obvious reasons, okay? I'm not sharing my credit card data with you guys. I don't have your credit card data. We should only have our own and nobody else's. Otherwise, somebody hacked your account, and we're not going to display that on YouTube, right? So just to be completely confidential and not disclose any sensitive information here, I just made up the data basically, okay? But it's pretty realistic. I think you'll understand, and I think you'll get the point pretty quickly here. And again, like we can't use real credit card data for this analysis for obvious reasons, right? Like nobody wants their credit card data in the public domain. So the first thing I did is create this data frame right here. You can see it's very basic. We have the month, or the date, rather, the date and the charge, and then the dining item, not dining item, I'm sorry, the item, I was looking at dining here, the transaction description, or the item that was purchased, right? Okay, so we have that. So the first thing I want to do here is create a chart. I'm going to use Plotly. I'm a big fan of these Plotly charts because they're dynamic, they're interactive. You can zoom in, you can zoom out, get all kinds of details about the objects being plotted here, and they're just very fun and very easy and dynamic to use. Let me see if I can modify this code just a bit. I just noticed something here. This chart is okay, but I would actually prefer it to be a little bit more I'd like to see the upper and lower thresholds. And I think it can be a little bit more explicit here because I was testing a couple different ideas I had yesterday. And this does show you the high and low, the different ranges over here. So here we see 200, we see a mean of about maybe 80 or so. This is that horizontal line right here, the dark line. We see the upper and lower threshold, and we see furniture here is an outlier here. Okay, so let me see here. Furniture is definitely the outlier, and over here, this is for January. If you go to February, we can see dining as an outlier and electronics, and then over here, dining again. So these are big charges that occurred on the card. So these might be legitimate. This might be a transaction I made on my card, and it's going to be totally fine. $800 for dining out one night seems pretty high given my historical purchase pattern, right? This kind of defies my purchase pattern. That's why it's triggered as an outlier or labeled as an outlier. And this doesn't really represent my normal credit card transaction, right? So electronics, 1,000, like 12,050. I mean, 1,250 and about almost 1,000. That does not describe me. I have some friends that would do that in a normal day. That's not my credit card transaction behavior. So the bank should flag this as unusual. Now, they may actually flag it or may not. Okay, so if this is a fraudulent transaction, hopefully your bank will pick it up. This might be legitimate, which is fine. If the bank picks it up, that's fine, right? They label it as fraud. If the transaction is actually fraud, but it's misclassified as a normal purchase, that is bad, right? So there'll be a misclassification and a mistake on the credit card company. But if you didn't catch it too, that's your mistake too, and you might have to eat it. Now, if you detected this and said, okay, this is not my dining charge, and this is not my electronic charge, and in March, this is not dining for me, and this is not electronics. Over here we have May dining and furniture purchase. So if this is what I did, that's fine. It is what it is. If it's not, we want to flag that with the credit card company, draw that to their attention, and we will get reimbursed for that charge, right? And the charge actually goes to the merchant that authorized the charge on the card because they didn't check the person's ID, right? Now you're supposed to check the ID. If the merchant didn't do that, that's unfortunate and they have to eat it. We don't have to deal with it, okay? So that looks a little bit weird. I'm going to get rid of that. That was just one other idea. Basically, we're looking at the box plots, the high, the low, the average, which is the mean, and then these outliers, which really exceed the high charges over here. We see furniture, and electronics, and this guy for October. This is October 2025. Hasn't even happened yet. It's only February 2025. Obviously, this is just made up data, but I think it illustrates the point pretty accurately. So we have furniture. So if you made the purchase, obviously you have to pay for it. If you didn't make the purchase, the credit card company has to be notified of that and you'll get reimbursed. Okay, so that's the whole point of this exercise. So this plot shows us the outliers pretty quick and pretty easily. But there's a few other ways that I want to show you how to deal with this kind of data. And of course, it could be credit card charges. It could be anything that has an extremely high value, even an extremely low value. That can be considered an outlier. And we want to detect these outliers. So it could be high credit card charges, fraud. It could be some type of, if you work in the banking world, money laundering, right? If there's a money laundering incident, that would be triggered as an outlier. That's unusual, erratic, irregular type of behavior that we have to be notified of as a bank or as a shareholder of the bank, either to boost shareholder confidence. We want to make sure that the banks are running their business in a smooth fashion, operating efficiently, and doing normal compliance routines in accordance with local laws and federal laws too, right? If they're not, we want to know about those money laundering incidents, any kind of fraud, any kind of weird credit activity. So there's all kinds of applications for this type of thing, right? So let me append 3 different fields onto our data frame, and this is basically going to look at 3 different clustering techniques. We have k-means clustering, db-scan clustering, and agglomerate clustering. And I'll show you just how easy this is. Here's the original data frame. We have month, charge item, right? Just made up data over here, small charges, medium, large, and then all charges. And then anything that is lower than 10 is a small charge, lower than 200 is normal. Otherwise, here's the else. Then these are large charge items. Okay, so dining could be $1,000, right? If you go to a nice restaurant, that's very possible. In New York City, I live in New York, you can easily spend $1,000 on dinner. You can drop a couple thousand or more on dinner, right? Furniture, electronics, travel, these are all big ticket items. Dining could be small, could be McDonald's. These clothing, electronics, dining, typically probably are smaller charges. Groceries, entertainment, groceries, dining, these could be small too, right? If you go out to the movies, you and a buddy, or you and your girlfriend or boyfriend or whatever, that could be $50 for the 2 of you to go to the movies, but relatively small charge, right? We're trying to look at these big charges too. But as I'm talking about now, you could focus on smaller charges if you had a reoccurring like Netflix subscription or subscription to Amazon Prime or whatever. If you have these recurring low charges that show up all the time in your credit card bill, and you have a huge credit card bill with hundreds or, God forbid, thousands of transactions, these smaller little tiny things could be eating away at your savings, right? And you might not even know about it. And it might have been months ago, 6 months ago, 8 months ago or more that you signed up for the service, Amazon Prime, some kind of Netflix, Roku, whatever the thing is, and it just keeps on going in a credit card month after month after month after month. You can find outliers that way too. It doesn't have to be a big charge. It could be a small charge, right? So it could go either way, but something that triggers your attention, and you can say, okay, this is not me. This is kind of a fraudulent activity or whatever. It doesn't define my spending pattern. I want to flag that. It could be low recurring charges, a subscription-based charge that you forgot about that you want to tease out of this analysis too, right? So it could be a big charge, it could be a little charge, it doesn't matter. But we're looking for some type of a regular pattern. So again, to tell you just how easy it is to do this, you have this data frame, month, charge item right here. You have 3 columns, super easy. We are going to do 3 different clustering techniques. We have k-means. So here's the algorithm right here. K-means number of clusters equal 3, db scan. We set this EPS to 5 and agglomerative number of clusters equals 3. Now in db scan, we don't choose the number of clusters, okay? That's determined for us by the algorithm itself. But in these other 2 techniques, we have to choose the number of clusters. Number of clusters is 3. Number of clusters is 3. And then all you have to do is fit that into the data frame. You always fit these models, whether it is classified, a classifier, or a regressor, both of which are supervised learners or unsupervised. Now we're doing unsupervised learning. You always fit the model, right? Call them all name fit, call them all name fit, call them all name fit. Df is the name of the data frame, and you append a new column onto your data frame, and you call it this. So here's the model on the right side of the equation. On the left side of the equation is the new data frame that you're assigning this model to. So here's the model on the right side of the equation. The equation is the equal sign. You assign it to this feature or this field on the data frame. Some people call it a column. Here's the model, right? It's doing the magic here and assigning the results from the calculation here. And you can see that right here. So k-means cluster, db scan, and agglomerative cluster. It's just that easy, guys. Like, super simple, okay? Very straightforward. Now that we have all the clustering done, we can go ahead and put this into a Plotly scatter plot. I like these Plotly charts a lot. I use these all the time. So if I go Google this, okay, Plotly scatter, and they have some documentation over here. Super easy to use. They give you the whole framework. What you put in is basically just this. Here's the data frame. Here's the x-axis. So the x is the width, right? Going linear across the bottom. The y is the height, right? Going vertical on the side. And then the color is whatever you choose over here. And then you can choose a size, right? So bigger sizes represent like a denser, bigger number, bigger count, bigger frequency, something like that. And smaller sizes just represent smaller numbers. It's exactly the same over here. You can just get that from the documentation, pop it in here. Here's the X, here's the Y, right? Here's the color. We're just giving it title, assigning some labels. These are all optional. You don't even have to do it. And then the color that I'm picking is over here, right? They pick this color right here, color equals species. This is a type of flower that they're looking at in this example. We're looking at colors of k-means clustering. So that's going to be the k-means. That aligns with the first column. Okay, db scan cluster is this right here, different color. And you can look close, you'll see different items here. These happen to be the same for the k-mean and that. Oh, it's actually displaying the entire data frame. That's good. So if I go down here, you'll see some differences. Wait, why is db scan? Let me see. db scan, they actually do something. No, that's fine. That's fine. Okay. Okay, just happens to be kind of similar there. So yeah, here's some differences. So these kind of line up sometimes, but then they're different sometimes too. Those are the same, those are different. And then agglomerative is kind of different. And I'll tell you in just a minute what the differences represent, right? Let me look at this. df.head. Okay. Just rerun that. So we just get the first 5 by default. You get the first 5 records there. So we go ahead and plot this. We will get the plot based on the k-means, the db scan, and the agglomerative right down here. So here's the k-means, db scan, and agglomerative. And again, you can see these outliers popping up, right? So if you zoom in, you can see all the details here. Here's all the little dots and everything. This is in between. So this is cluster 1. This is cluster 2 down here. And if you go up here, we actually have a cluster 0. Okay, we have cluster 0 over here. So these zeros are outliers, and these are the normal types of clusters. If we zoom in, we can see cluster 1, cluster 2. So there's a lot of 1s and 2s. There's a couple zeros, and these zeros are outliers. Okay, over here we have an outlier is 1. This is cluster 1 in the db scan side, and in the k-means you see cluster 1, and then these are more of the normal non-outliers, normal transactions on your credit card. So cluster 0, 2, and then cluster 1 over here. So it doesn't matter what the cluster is, whether it's 1, 2, or 3, makes no difference whatsoever. We're just looking at these outliers that are above the normal pattern that you would expect. So this is interesting. In K-means in January, it's saying this electronics purchase for $14.71 is an outlier. It certainly looks like an outlier. That's pretty high. DB-Scan actually claims that this is an outlier. This is cluster 1. These are zeros and 2s down here. The 2s, I think, fall right in there. Where's it go? Hard to see those. But this is the outlier. So here the outlier is cluster 1, and it's $915. Here the this is also cluster 1, and it's $14.71, right? So these two, electronics $12.63 and $9.82. This is $9.74 and $7.76. So depending on which clustering technique you use, some of these might be outliers or might not be outliers. In this case, I think they're both picking up the same outlier, 1301 and 1142. This is 1365 and 1171. So it's picking up slightly different things, but different clustering techniques, right? And the agglomerative has its own sort of flavor here. So if we look at this, K-means basically partitions data into K clusters. It really performs well on clusters that are kind of circular in nature or have kind of similar data points between one cluster and then another cluster as its own and another cluster as its own, right? So cluster centroids will define the center of the cluster, and all the points that are homogeneous to that are pulled into the same cluster. If they're heterogeneous, they go to another cluster, another centroid, and if it's different, it goes to another one and another centroid for the other cluster, okay? So density-based clustering is a little bit different. It looks at groups of points based on their density or regions. That's why it's called density-based. So DB-Scan looks at densities of regions to define a cluster, and this is more where you don't define the number of clusters beforehand, right? You define, or the model will define the clusters for you. K means you have to define the number of clusters. Remember, we picked 3. Here we picked none, right? The algorithm defined it for us. And with agglomerative clustering, yeah, it's hard to say that, then you define the number of clusters just like K-means, right? But it's more hierarchical based. So instead of looking at centroids and our cluster data points close together or far apart and they go into another cluster, you're looking at hierarchies of clusters, right? So think of a dendrogram type of arrangement, okay? And there's the advantages to this. Does not require a number of clusters to be specified up front, okay? And disadvantages is computationally expensive and may not scale well for large data sets, right? So you really have to understand what the objective is here and what you're trying to achieve, and then pick the right algorithm. Of course, you can run all 3. In this case, we ran all 3, and you can look at the results and then compare and contrast those, and then pick the right clustering algorithm too. And I've got a video on actually shows you how to pick the most appropriate clustering technique based on the outcome of each one. There is a statistical method that you can apply. I'm not going to get into it now because the video would drag on, but I have a whole nother video about how to compare these on a statistical basis to see which one is performing better and not just eyeballing it. Here we're looking at this and saying, this is an outlier, this is an outlier, these are outliers here, and I'm also with this and these are outliers, right? But there's actually a more methodical way to prove beyond a reasonable doubt using a statistical approach, and you can prove which algorithm is better. So you might want to look into that as well. So here's 3 more techniques, and then I think we can wrap it up. So z-scores are another approach to looking at outliers. Here's one outlier here. So we have, a little bit hard to see it, 1471, that looks like an electronics charge. This is actually an outlier furniture. This is not an outlier. So you can see the blues are not outliers, the reds are. I like these Plotly charts because you can turn it on and turn it off. There's the red on and red off, and blue on and blue off. These are just outliers, right? So this is actually an outlier. The 974 for furniture, 776 for travel is not an outlier, even though these 2 are pretty close. One is unusual and one is not. But if you look over here, both of these are treated as outliers, right? For these other clustering techniques that treat both as outliers, but the z-score just treats the top 1 as an outlier here, the top 2, top 1, top 2. This is outlier in red and this is not in blue, okay? So there's a bunch of different techniques that you can use if you really get into it and you really want to be absolutely certain. Now, interquartile range labels both of these as outliers, right? So here, this charge for 776, I think, that's hard to read, and can't even read this. Sorry, guys. The light is in my eyes. Whatever. Both of these are outliers, right? Based on the IQR method for outlier detection. And over here, this blue dot right here, now you can read it. 776 is not an outlier, but this one that we can't even read, I think we have to fix that color, make it orange or something. This is an outlier and this is not. When you use IQR methods, this is an outlier and this one. So both of them, right? And one more approach to consider is isolation forest. So here, both of these are outliers, like we saw before with the IQR. This is an outlier, 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 outlier. This is an outlier, outlier, and this is May, June, July. We have one outlier. June, we have two. And June is a little bit unusual here, very unique, but I'm going to go with the way that this model is working and not question the model because it's doing what it's supposed to do. They always do, but the data might be coming in just a little bit funky because the lower data point here is actually an outlier. It's red and it's labeled as an outlier, and the blue, which is actually higher, is not an outlier. So that's a little bit unusual. Here you have the reverse. That's what I'd expect. Like the higher one would be the outlier, the lower one is not. Here we have two outliers in July or August. They kind of blend together here. This is September, October, November, December, July, August. Oh, I guess it's August. You have two outliers. Here you have one. Here you have one outlier in the top, one non-outlier just underneath, and these are reversed. So that's very interesting, right? But again, I'm sure the model is doing what it's supposed to do. It's just a little quirky data set here. Okay, so the z-score is good for a couple different things. Like we saw the 3 clustering techniques. Basically, you would use this because it measures how many standard deviations the data point is from the mean. So you'll have the mean, which is the average, 1, 2, 3. Beyond 3, you get a higher z-score, and that gets kicked out into an outlier. This is clearly 3 standard deviations from the mean. The mean is probably down here somewhere. This is beyond 3. IQR interquartile range. This is used for percentiles to find the normal data points and identify outliers. And isolation forest is a tree-based unsupervised learning model. All these are unsupervised, right? All the clustering techniques are unsupervised. And it isolates anomalies faster than normal points. So you would use this if speed is an issue or computational power is kind of a impedance. It's impeding your progress or something. So this is a more elegant, more efficient type of algorithm than some of these outlier detection methods, right? So this one's pretty efficient. So that's it. I've got my notes in summary right up here: z-score, IQR, isolation forest, and I will let you read that. I'm going to share all these notes with you when I post a video later today. And I have 3 clustering techniques on my notes on that: k-means, and then db-scan, and then agglomerative clustering. God, I love that word. Whoever came up with that name was a very creative person. So that's it. There's 6 different techniques, and there's actually other clustering techniques too. Take a look at this. This is the documentation for plotly scatter plots, and I'll show you one more. Now we'll wrap it up. Google scikit-learn clustering. I love this site, KIT-learn. And if you go over here to clustering, the first one that comes up, you'll see a whole bunch of different techniques. I think there's 11. So we have mini batch, affinity, mean shift, spatial, word clustering. I've never even used that one. Agglomerative, that's what I showcased here. So that's 6, 7, 8, 9, 10, 11. DB scan, optics, Birch, and Gaussian mixture model. So there's 3 more that you can try and read up on the documentation how those are different. These are the primary ones. That's why I want to showcase that. But there's several other clustering algorithms out there, and each has its pros and cons depending on the types of data sets that you're analyzing. Okay, so I've got a couple more notes here to summarize. Z-score, IQR, we talked about that, and I think that's it. I mean, I could talk on and on about this, but you don't want to hear me filibuster ad nauseum. So I'm going to wrap it up. That's it, guys. Thanks for your time today, and keep an eye out for the next video. I'm going to drop 1 per day on average. Sometimes I do 2 per day, sometimes 3 if I miss 1 day in between or 2 days in between. But I try to do 1 per day on average, and I'm trying to get up to 365 videos in 365 days. I'm right on target with where I need to be. I'm almost at 200 videos, and I'm 200 days into this project. Okay, so keep an eye out for the next one. I'll drop it soon. Thanks. Bye.